Hello everyone. Okay, this video I'm going to talk about the next chapter. After introducing Newton's law, and next chapter I'll introduce the energy and work. Okay. Okay. So actually we heard the energy this term a lot. Okay, but actually when you Google the energy and on Wikipedia, okay, you will find the energy is a very late terminology in science. Yeah, let's scroll down this. If you from Wikipedia, you will see that Thomas Young is the first person to use the term energy in modern science. Yeah, it is about 19th century. Before 19th century, we really don't know what's so-called energy. Before 19th century, we all know the force and momentum because of Newton's law of motion. Okay, and the other is things is the energy conservation. Energy conservation in today, we always we think energy conservation is kind of a common sense. But before 19th century, that's not true. Before 19th century, we don't know anything so called. We don't know something so called energy conservation. So energy conservation is are very late comes up very late in science history. Okay, so let's go back to the slide. So, what first of all, what is energy? But actually, it's a very difficult problem. Now, what is energy? What is energy? It's very difficult to answer. So let's start from the description from Wikipedia. It says energy is a quantitative property that is transferred to a body or to a physical system recognizable in the performer's work. Yeah, that's a very academic sentence. Okay, in simply sentence, that means energy is something can add into your system or object. Okay, and then performing the work. Okay, we'll talk about what's work. Okay, okay, so here he said energy is something we can add into a body or physical system, but at the same time, you maybe at in the second year in your in engineering department, you will learn a subject called engineering thermodynamics. At that time, you will find that actually sometimes your body or system can also transfer energy from the body or physical system to outside. Okay, here in physics textbook, you always talk about adding the energy into an object or physical system, but this can be reversed. Your body or your physical system can also transfer energy from inside to outside. Okay, and this also can do work. Okay, so you can do work on your body and system, and also the body or system can do a work to outside. Okay, and in addition, okay, in thermodynamics, engineering thermodynamics will also tell you not all kind of energy can perform work, because from the first description of energy, you might think all kinds of energy can do work, but that's not true. That's not true. Not certain kind of energy can perform work, but not all kinds of energy can perform work. And you will learn this in your engineering thermodynamics. Okay, I don't want to address this issue more because it's kind of complicated concept. Okay, so from the first two description, we still don't know what the energy is. Yeah, yeah, that's true. Energy is an abstract concept. It's not really something concrete or touchable. Yeah, you cannot touch energy or hold energy on your hand and so called, oh, this is energy. This is energy. I'm holding energy on my in my hand. That's not so energy is not something concrete, but in animation or comic books, we see lots of character can hold energy and do some attack, as like Dragon Ball Z. These two animations is copy from Dragon Ball Z. You see the character is Wukong is Dar. Okay, they can hold energy on their hand and do some attack to other people. Yeah, that's comic books, and that's only happens in comic books. Yeah, but in reality, we cannot grab the energy, grab energy in our or touch the energy. Okay, but uh, but but we can feel the energy. We can feel the energy. Okay, that's the next slide. We can feel the energy. Okay, we can feel the energy by work, heat, and light. work, heat, and light. Work, heat, and light. Work, heat, and light. So work, heat, and light are the expressions of energy. Okay. Yeah, energy we cannot see it or hold it or touch it, but we can feel it or sense it. Okay. And let's use a diatom electric part as an example. The right hand side is a diatom electrical part. Okay, this is the most powerful product produced by Taiwan industry. Yeah, and in this electric power product, no, not electric product, in this electrical part, yeah, it's designed for cooking dishes. And in this electric part, okay, you have to add a little water here. Maybe here this is the water. You have to add the water there. Okay, water there, and you turn on the electrical part. It will you turn on the electrical part. It will heat. Okay, there's the heating steel here. But let's just draw this. If I turn on, it's heated water, and the water can transform to the steam or vapor. Here it's a steam, water steam. Oh, not water, steam. It's just steam. Okay, it's steam or vapor. Is a steam also gas? Okay, let's call it steam. Okay, it's a steam. Or after you heating the water liquid state become gas state. So that's a steam here. And this steam, okay, and then this steam will move randomly. And then as it's cooking, you'll feel the vibration on the top. Yeah. Did you remember observing this? Did you observe this when, as the bottom electric bulb cooking? You feel the vibration on the top. On the top, you feel the vibration. This steam, yeah, they are pushing the top. Well, that's why the top is let's cause the vibration of the top. Okay, so the gas is doing work on the top. Okay, gas and steam. Let's say steam does work to the top. Okay, so since the work is an expression of energy, so we can say that some energy is in this steam, some energy is in this steam, and this energy do the work. You know, and this energy is expressed by the work. Okay, and the work and cause the vibration of the top. Okay, and also as the electric part is doing the cook, okay, if you use your hand, your hand is close to the top, you will feel the heat. Okay, you will feel the heat. Okay, and heat is also the expression of energy. So you can, if you feel the heat, okay, you can say, yeah, I feel the heat from the electrical part. Okay, so that means there's some energy. There are some energy in this electrical part, and that's why I can feel the heat. I can feel the heat. Okay, so energy, so work and heat is an expression of energy. And also light is also expression of energy. Okay, so there's a different color light balls. Okay, in light balls there are some materials also, or maybe a phosphorus. Okay, phosphorus. Yeah, I think it's phosphorus. And the light bulb, when you use light bulb, you have to put the electrical energy in your light bulb, right? If you need electricity, that means you put the electrical energy into your light bulb. Your light bulb has a phosphorus, and in phosphorus, in quantum mechanics, okay, every material has energy level and fill in the electron. Okay, this occupied state and unoccupied state. So when you input your electrical energy into your phosphor, the phosphor is a material in the light bulb, and your excited electron, let's say it's excited one electron to higher energy state. Okay, so let's say the energy is high in this direction, energy high, high energy in this direction. So there's a high energy state, And the electron, this small arrows represent the electron, spin up, spin down electron. Yeah, I know you don't understand what's called spin up, spin down electron, but let's just accept this word, okay? You will understand it very late, okay? And then later of your undergraduate, okay? So the electron doesn't like a high energy state, so it will goes down. You want to go back to its original state, okay? And once it go back from high energy state to the low energy state, it will release. It will emit the light. Okay, HU is called light. Okay, so that's why I say light is also the expression of energy. Okay, so this electric, yeah, no, sorry, in this light bulb, you input the electrical energy into your phosphor material in a light bulb, and this energy excited the electron in the phosphorus from the lower energy state to higher in the energy state. And in the electron, when the electron go back from a high energy state to the low energy state, it will emit light. Okay, so light is the expression of energy. Okay, so yeah, we cannot touch the energy or hold the energy. So energy is not real subject, but we can feel it and can sense it. Okay, that's the that's the energy. Okay, and what else in energy? What else in energy? So energy, yeah, it's interesting. Energy can flow in and flow out. Okay, energy can flow in and flow out. That's very interesting. It sounds like it's like a fluid. It can flow in and flow out. Sounds like it's a fluid, but it's not a real fluid because, like I said, it's not real substance. It's not real substance or object, but it behaves like a fluid. It can flow in and flow out a system, and it also can change from one form to another. Okay, it can change from one form to another. So, for example, when in later lecture, we'll see the kinetic energy and potential energy. They can transform from one to another. Your kinetic energy can transform to potential energy, and your potential energy can transform to a kinetic energy. And the kinetic energy and potential energy is we so called the macro is for one macroscopic object. And these two energy is also called mechanical energy. And mechanical energy is for macroscopic objects. Okay, so you might think, is there any energy for microscopic object? Of course. Okay, well, we'll introduce this in the next slides. For macroscopic object, what interesting is in the kinetic energy and potential energy, and they can be transformed from one to another. And the kinetic energy relates to the motion of object, and it relates to the velocity of the object. Okay, and we will show this later. And potential energy relates to the configuration of system or configuration of your object. Okay, and we'll introduce in the later chapters. Okay, and energy is conserved. Yeah, it cannot be created or destroyed. Energy is always there. Okay, it's conserved. Okay, so what else in energy? Let's see what else in energy. Yeah, like I said, we have mechanical energy for macroscopic object, and in terms of the microscopic object, we have a term called internal energy. And internal energy is caused by the random molecular motion and configuration of a molecule. It's called internal energy. And internal energy can also be transformed to a potential energy, and they can be transformed to potential energy. Potential energy can also be transformed to the internal energy. And so once your system doesn't have energy flow in or flow out, the energy of your system is conserved. Okay, that's very intuitively. Yeah, if no energy flow in your system or no energy flow in or flow out into your system, your energy of system is conserved. Okay, it doesn't change. The amount of energy in your system doesn't change, and it can be transformed it can transform from one to the another. Okay, even if in the next semester we will introduce electromagnetism energy, the electromagnetism energy can also be transformed to potential energy or kinetic energy of the system. Okay, so energy is a very, yeah, we actually it's hard to describe what is energy because it's so weird. It act as a fluid, but it's not a real fluid. It also can be transformed from one to another. Because for real object, I say one object can transform to the other object, you might think I'm crazy. So also I say one person can transform to the other person. It's counterintuitively, but yeah, the energy can transform from one to the other, and this concept works. It can help us to solve lots of problems. So you cannot say it's wrong, okay? But although we cannot prove it, but we cannot prove it right. But at the same time, we cannot prove it wrong. Okay, so the concept energy we keep using this concept from the energy. Yeah, you cannot prove it right, but it works, and you cannot prove it wrong. So let's just keep using it. Okay, so okay, it's very hard to explain what energy is. Okay, so in the next video, I will start to talk about work. Okay, so I'll stop the video here, and we'll see you in the next video. Bye bye. Okay. Oh, how to. Okay. See you. Bye bye.